So homework 23 starts off with writing the equation of a vertical or horizontal line through a given point. When we had vertical and horizontal lines, they were special cases. They weren't the normal y equals 2x plus 3. They either had an x equal or a y equals, right? If my line went straight vertical, it always said x equals and I just had a number behind it. If it was horizontal, it always had y equals and it just had the number behind it. So it says they want you to write the equation for the vertical and horizontal line that passes through this point. If I just sketch out a little graph here and I have 1, -4, and my dot's down there, I want to write the two equations, one being a vertical line, one being a horizontal line. Well, we know that our vertical line always has to start x equals. By the way, if you don't put the x equals in there, it's going to count it wrong because then you're not going to have an equation. And if it's going to be a vertical line and it's going to touch this point, it's going to have to be that straight up and down line that touches the x-axis at the x value of the point. So in this case, it would have to be the line x equals 1 in order to touch that point. If I were going to draw the horizontal line that touches that point, it would go like this, if I could draw straight. We know that if it's a horizontal line, it's going to go y equals, and in order to touch this point, the y value would have to be the -4. So did I really have to draw that to write those equations? No. I can for fun though. All I have to be able to do is look at that ordered pair and know that the first value in my ordered pair is your x value and the second one is my y value. So on number 2, it wants us to write the equation for the vertical and horizontal lines that pass through the point 8, 0. So my vertical line would be
8,
x equals 8. And my horizontal line would be y equals 0. Number 3, we want to write the equation for the vertical and horizontal line passing through the point 9, 8. So the vertical line would be x equals 9, and the horizontal line, y equals 8. Now sometimes they like to try to be tricky on you and ask for the horizontal line first, so make sure you read and don't always just get used to doing x equals first, because sometimes they'll switch them around on you just to see if you're paying attention. Four, 5, and 6 are talking about domain and range. So they're getting into some fancy math words. It says, suppose that the relation S. Relation is just a fancy math term for a set of ordered pairs. So if they're talking about a relation, they're talking about a set of points, a set of ordered pairs. So we have a set of ordered pairs there. We've got 4 points in that set. They want us to give the domain and the range of S. Domain is the fancy math word for listing the x values. And the x values are always the first ones in your ordered pair. The range is your fancy math word for your y values. It says write your answer using set notation. That means before you put your answer in, you're going to click on the thing that puts the little set symbols around your answer.
So domain is the x values?
The domain is the x values, the range is the y values. So if I'm going to list my domain, in my first point the x value is 2, in the second one it's -6, in the third one it's 0, and in the fourth one it's -6 again, but I already have it on my list, so I don't need to put it in there a second time. It's already there. If I'm going to list my range, I'm listing my y values. So in my first point I have a -3, in the second one I've got a -1, in the third one I've got a 2, and in the fourth one I have a 4. None of those repeated, so I have to list them all down. And that's all they're trying to get across. So what does the word domain mean? What does the word range mean? Domain is your x values, range is your y values.
So why didn't you put -6?
Because I already had it.
Oh, okay.
It's already
So
in
you
my
don't
list,
have to-
so I don't need it more than once.
Okay.
If you put it in there, it'll say it's correct, however, it's already in your list, you don't need to put it in there more than once. So number 5, if I'm going to list my domain of M, I'm going to have what in my domain? 4, 9, and 3, right? In my range, if I'm going to write my list in my range, I'm going to have an A and a 9. Again, the A is in 2 of your points, but you don't really need to write it down more than once. It's the same thing. So number 6. I want to list my domain. My domain is going to be -1 and -2. And my range, -2, 1, and -1. So easy enough once you know what domain and range mean. Number 7, I really don't know why they don't put this on your pie chart before they have you do all that graphing, but they don't. They have you fill in what's called a function table. It's just like when we did the X and Y in our table when we were graphing all our points. H of X is what they call functional notation. It's the same thing as having Y equal something, but it's a way to name your lines so that if you have 3 or 4 lines on the same graph, you can call one H of X and one G of X and one F of X, so you know which one goes with which equation. So this is just the same thing we've been doing. I'm going to substitute the number in for the X, but I'm really only doing the work on the right-hand side. I'm finding what my answer is if I put -3 over here on the right and solve it. So, first one is written like this. They'll do this. H of -3 to tell you, oh, I'm putting -3 in for my X. And then they're going to do it on the other side. 4 times -3 minus 5. I don't know why I put that parenthesis there. I was just busy writing. And then I'm going to find the answer to that. So 4 times -3 is -12. -12 minus 5 is -17. And so I'm going to put it into my table. When X is 3, my answer is -17. So then they tell you on the next one, well, let's use -2. So they're going to write it as H of -2 to show that, oh, -2 was the number I'm putting in for my X. But I'm really going to put it in on the other side. 4 times the -2 minus the 5. And then I'm just going to solve that right-hand side. 4 times -2 is -8. -8 minus 5 is -13. So when X is 2, my answer is -13. So the next one says I'm going to do 0. H of 0 would be 4 times 0 minus 5. If we solve that one, we're going to have what? Four times 0 is 0, and 0 minus 5 gives us -5, right? And then we get to do the next one, which says to do H of 1. So 4 times 1 minus 5. 4 times 1 minus 5 would give me
-1.
-1. 4 minus 5 is -1. And then last but not least on this one is 3. H of 3 means I'm going to do 4 times 3 minus 5. If I do 4 times 3 minus 5, I get 7. 12 minus 5 is 7. If you would have a graph that was big enough and you plotted all 5 of those points, they should all line up in a nice straight line because we have what's called a linear equation. A linear equation is what we've been graphing. They all graph like lines. They just have a plain x in it. It doesn't have a squared or a cubed or any weird things like that. So they call that a linear function because if I put them all on a graph, they all end up in a straight line. And that's why I don't know why they didn't do those first. So, number 8. We're going to start and figure out what h of negative 5 is. So on h of negative 5, what are you going to do? Negative 2 times negative 5 plus 4, which gives us an answer of?
10 plus 4.
Which is?
14.
14. We get 10 plus 4, which is 14. And then we're going to do h of negative 1. So if we take negative 2 times negative 1 plus 4, we get an answer of?
6.
6. 2 plus 4 gives us 6. And then we do h of 0. Negative 2 times 0 plus 4. Gave us that nice end number 4. We did all those with the y-intercepts. And then we do h of 3. So negative 2 times 3 plus 4. And our answer is?
6 plus 4. Negative 2.
Negative 2. Negative 6 plus 4 is negative 2, right? And then we have to do the 4. So h of 4 would be negative 2 times 4 plus 4. Gives us an answer of negative 4. Negative 8 plus 4 is negative 4, right? Number 9. We have h of x equals negative x plus 1. Now again, keep in mind if you have trouble with that negative x, what's another way you can write negative x?
1x.
Negative 1x. So if it helps, write it as negative 1x plus 1. Otherwise, on Alex, you would probably see them write this. They'd have minus, and then they're going to put the negative 1 in, plus 1. When you do minus a negative 1, you get a positive 1. And 1 plus 1 is 2. Or if you did negative 1 times negative 1, you still get positive 1. So they probably won't put the 1 there, but if you need to and it helps you out, put it there. h of 0. We'd have minus a 0 plus 1. My answer on that would just be?
0. No, plus 1.
Plus 1, because this would be 0, and 0 plus 1 is 1. And we're going to do h of 1. So I have minus, and then in parentheses is 1, plus 1. If I figure that out, I get an answer of 0. Right? Negative 1 times a positive 1 makes that negative 1, and a negative 1 plus 1 is 0. h of 3 minus a 3 plus a 1. So I would get an answer of negative 2. Negative 1 times 3 is negative 3, and negative 3 plus 1 is negative 2. And then h of 5. So minus the 5 plus the 1 gives me an answer of
Negative 4.
Negative 4, exactly. So that's what they call function tables. And the last 3 is actually sneaking into the next chapter, but for some reason they put it on this chapter. Checking to see if an ordered pair is a solution to a system of equations. A system of equations just is referring that you have more than one equation. In order to be a solution, you have to get yes for both of your equations. We already did them with one equation. Now we have to get yes for both. So if you substitute it into the first one and get a no, there's really no reason to check the second one unless you just want to practice. If I'm going to do the 0.14 and I check it in my first equation says y equals 8x minus 4. I'm putting 1 in for the x and 4 in for the y. So I'm saying does 4 equal 8 times 1 is 8 minus 4?
Yes.
Well, if I do 8 minus 4, sure enough, that works. I get a yes. So it checked in the first line. That means I better check it in the second line. I have to get a yes and a yes in order to answer yes to the question. So I have negative 3 plus 2 times the y value. The y, I think she didn't put a variable in there when she typed that. Let me fix that. I think that's supposed to be negative 3x. There. Put an x behind your negative 3. So now if we check it, we're going to take negative 3 times the x value, which is 1, plus 2 times the y value, which we have is 4, to see if we get 5. If we solve that, do we get 5?
Yes.
Yes, we do. Negative 3 plus 8 is 5. So we got a yes on the first, a yes on the second. We get to answer yes for the solution to the system. It worked in both of them. So when I look at the next point, because if you get a no on either of them, you know it's going to be no. Which one is easier for you to substitute into? Do you want to use the first line or the second line? The second line. Okay, let's use the second line. So we're going to take negative 3 times negative 7 plus 2 times negative 8 to see if we get an answer of 5. We do get 5. 21 minus 16 is 5. That means we've got to check the other line. So now we've got to check our other line. Y equals, so our y value is negative 8. Does that equal 8 times the x value? So 8 times negative 7 minus 4. So if you take 8 times negative 7 minus 4,
Nope.
no, that doesn't work. So since this was a yes, but this was a no, the answer is going to be no, because in order to be yes, it has to work in both of them. So then we get to check the next point. See, these ones aren't short. So, do you want to try it in the first line or the second line first? Doesn't really matter. You guys are just busy working away. The first one? So in the first one, the y value is 5. Does 5 equal 8 times the x value? So 8 times negative 3 minus 4.
Nope.
No, it doesn't. So we don't even have to check the second line because it didn't work in the first one. And then we're going to check the last point. Do you want to check that in the first or the second line? The first line, okay? So my y value is negative 4. Does that equal 8 times my x value, which is 0, minus 4? Oh, so it worked in that one. Since it worked in that one, we now have to check the second one also. So negative 3 times the x value, which is 0, plus 2 times the y value, which is negative 4. Does that give us a 5? It gives us negative 8. That's not 5, right? So since this was no, even though that was yes, we're still going to say
No.
no. So number 11, checking 6, 0 in our first line. How would we do that?
times 6 plus 9 has to equal 0.
And does that equal 0? It's negative 3. So we don't have to check the second line. It didn't work in the first line. So then we can hop to the second point. If we check the second point in our first line, we would have what?
In our first one?
The second point in the first line, yeah?
4. No, negative 2 times 4.
Negative 2 times 4 plus 9, does that equal?
Equals 1.
1.
So that works in that
So
one.
that one works in that one. So since it worked in that one, now we got to check the second line. So checking the second line, we would do what?
4 times 4 plus 2 times 1 has to equal 18. Oops, error.
Whoop, try it again then. Equals 18. So we got a yes and we got another yes. We get to mark yes. So now we check the third point. So on the third point, negative 2 times, what number?
5.
5 plus 9. Does that equal the minus 3 of our point?
1, no.
Nope, so we can just say no. Uh-huh.
On that 4 times 4. Oh, never mind. Okay, never mind. I got it.
And then we can check that last point. So negative 2 times 5 plus 9, does that equal? So that one worked on the first line, so we got to check the second line. So checking our second line, 4 times negative 5 plus 2 times 19. Does that equal 18 when we're done?
Yes.
Yes, it does. We got a yes and a yes. Hey, we got 2 yeses on that table. And one last set here. So, checking the first one. 2 times the 0 minus 5 times our negative 7. Does that give us an answer of 4?
Nope.
Nope. Since that's no, we can just mark no. So we check our next point. 2 times negative 8 minus 5 times negative 4. Does that equal 4?
It's 4.
It does equal 4. So now we've got to check the second equation. So negative 3 times negative 8 plus 2 times my y value, negative 4. Does that equal 5?
16.
It equals 16, so it doesn't equal 5. It's a no. So then we go back to our first line and our third point. 2 times negative 3 minus 5 times negative 2. Does that equal 4?
Equals 4.
Okay, so it worked in that one. We got to check the second one then. So negative 3 times the x value of negative 3 plus 2 times the y value of negative 2. Does that give me 5? Yes, it does. So we got a yes and a yes. Our whole system then is a yes. And one last one to check. Putting in the 1 and the 4. 2 times 1 minus 5 times 4. Does that equal 4? No, it doesn't. So in order to be a solution to the system, it has to be a yes on both equations, otherwise it's a no. Alrighty. That is the end of the chapter.